use function notation to show that whatever's inside here, the inside, can replace the x in the function. Okay, so we're going to differentiate between the inside part, where we have this part here. This is the inside, or my input, or my domain. And when I input it into here, the output is going to be that whole calculation, or this f of x. So f of x represents y. And so the f of x there actually has an inside and outside. So there's my inside, and then we have an outside here. Okay, and the inside is x, the outside really essentially represents y. So we can use function notation to differentiate two functions, but we can also use this algebraically and just say this function notation f of x represents this variable expression, and this function notation g of x represents this variable expression. And so we have this inside x, and we have this outside g, or the outside f, and that inside and outside represents our input and output, our domain and range. And then we can do some algebra on this. So here we have f of x minus g of x. Well, I'm going to subtract this expression, this y expression, with this y expression. And what ends up happening is all I do is I take my f of x and I algebraically replace it like for like. An equivalent for f of x is this expression here. So I'm going to take that f of x and replace it with 4x squared minus 3x. Okay, there's my y for f. And then I have my g. I'm going to replace that g of x with this expression here. That's an equivalent to g of x. So I'm going to replace this g of x with this expression x squared plus 5. Okay, and this f of x minus g of x expression then is this variable expression that I've written here. So I'm just going to move it over here. Those are equivalent. And then I can simplify this expression because I have like terms. So I end up with 4x squared minus 1x squared. I have negative 3x. And I have minus plus 5, so minus 5. Okay, make sure you use brackets whenever you're doing these substitutions. So this new expression, when I combine two functions together as f of x minus g of x, is going to be equivalent to this x expression here. So here we have our 2 on the outside. That's going to affect our f of x. That is a times. Okay, here we have a minus 4 times g of 2x. So we have the 4 and 2 on the outside. Here we have a 2x that we have to replace on the inside. So now we have an inside substitution and an outside substitution. So we'll start with the 2 times. Okay, we should use brackets whenever we're doing any kind of substitution. My f of x is going to be 4x squared. Okay, so it's going to go back up here, 4x squared minus 3x. And then we have minus 4 times. Again, we're going to now use brackets here for our g. So we have g of x, which is x squared plus 5. Now we're going to do the replacement, an inside replacement for 2x. So we have to make sure that we account for that. So this is our x squared plus 5. Okay, so there's our g of x. Now to make a g of 2x, we need to replace the 2x wherever we had an x. So just going to highlight this. This inside 2x has to replace the inside x over here. Okay, so now I've done my replacements. I've replaced my outside and inside. Okay, I'm just going to move it over here. This is my new expression. This expression represents an equivalent expression to this function notation expression. So now I'm just going to expand and combine my like terms, just to simplify this expression. Minus 4, I'm just going to keep this in brackets for now. This is going to be 4x squared plus 5. Okay, make sure the brackets are important because of that negative. If you lose track of that negative, if you don't keep organized and keep track of your use brackets, your substitution. So I'm going to minus 16x squared minus 20. Okay, that's where most people make mistakes. Then combine my like terms, I end up with negative 8x squared minus 6x minus 20. So there's my new expression for my 2f of x minus 4g of 2x. Okay? And this is the expression that represents that new function when I combine it like that. So I can combine those functions algebraically. We have outside changes and we have inside changes. So here, there's my inside. The black represents the outside changes.